In this video, you will be able to understand the application of KCL, that is node voltage analysis, and to find the unknowns. It may be voltage, current, power, or any other electrical quantity. There is even resistance also. Here you will also be exposed to the concept of branch, that is the currents flowing in the branch. What is node, what is the junction, and some other parameters related to node voltage analysis. So I am Mohan BS, Assistant Professor working in Department of EEE, AJBIT.
So before we actually solve my node voltage analysis, let us understand some concepts related to it. So we'll again take back how do we find Vx and Ix in the upcoming slides. So let's neglect this, and with respect to circuit, let us understand. By the end of the video you should know what is node, junction, branch, how do we apply node voltage analysis, how do we find voltage and currents, in this case Vx and Ix. Node, what is node? Node is defined as a connection point between two or more elements. So between two or more elements. So which are the nodes here which forms a connection of two or more elements? So we have marked them here in red dots. Let us name them from A to F. Let us see what is a junction. A junction is defined as a connection point between three or more elements. It's defined as a connection point between three or more elements. So you can see node is within a junction. So out of these nodes you have to identify which all or which are the junctions. I hope this will not be difficult. At point B is one of the junction. So let's see the other junction which is there. So let me help you out in understanding it. So let's see, point A, we have two ends, two elements, 28 and R1, and B, as you know, we have three elements, R1, R3 and R2. So it's a junction within a node. C, R3 and 7, it's a node. Now before we go to D, E and F, can we say this circuit and this circuit both are same? They are same electrically, but what is the difference? What difference do you observe? They are same, but what do you observe? What difference do you observe? Here between F and D there is a line, E and D there is a line. This line represents connecting wires, whereas in this diagram we have removed the connecting wires and connected each end of 28, 2 and 7 directly without help of connecting wires. Thus we can say that F and D, which was a node, now all these three forms one junction holistically. So we have two junctions highlighted in yellow color, right? So we can say that junction as either F, E or D. So I think we have named it as point D. So let us see this further. So we have only two junctions which are B and either D, either E and F. So we have named them as B and D. So we have two junctions here. So the circuit can also be written in the syntax. They are still same electrically. So 7 and 28 are in series, and then 2 ohm is between two junctions, and then 1 and 7 are in again series. So the circuit is still same electrically. This will help you to understand further. That's why we have rewritten in this syntax. Now let us see the third element, branch. What is a branch? Branch is defined as the connections or the path, the number of paths or number of connections between junctions. So here we have two junctions. So between these two junctions, how many paths one can observe, or how many connections are there between these two junctions, between B and D? So one can observe that we have three paths, right? So we have named them as I1, I2 and I3. We have three currents. But why have we named, or why have we addressed the currents downwards? Why is it flowing from B to D, not from D to B, right? So let us answer that. So here we should assume one as reference point, that is black color, as ground potential, and the rest, in this case only B, the other node which is there, or the other junction which is there, has highest potential, right, or positive terminal. And we know that current flows from positive to negative. So we have assumed as point B as positive, and we have assumed point D as negative. Thus the current flows from positive to negative. Thus all the currents, in this case all the three currents, I1, I2 and I3, are flowing from assumed positive to assumed negative, right? So we have three branches. We assume all the currents are leaving the junctions. if we apply KCL at point B, we can say as current entering is equal to current, when we analyze with respect to current entering is equal to current leaving, one can write 0 is equal to I1 plus I2 plus I3, right? So what we have seen, you have seen two junctions, you have seen three branches, we have assumed point B as positive, we have assumed point B as negative or ground potential, and in general, how do we say that, how can we find the number of unknowns? So the unknowns by nodal, the unknowns are voltages. So how many voltages are unknown? How do we find? So number of junctions minus 1, right? So number of junctions in this case is 2 minus 1, that is only one unknown, that is at point B. What is this minus 1? So minus 1 is your reference potential. So we know at reference your voltage will be 0, right? So we always neglect one of the junctions, that is ground potential. So if I have three junctions, I can say that one is ground potential, thus we have two unknowns. Similarly, if we have four junctions, we can say that one is a reference, thus we have three unknowns. It's in general. We'll see how does it changes with respect to numericals. So point D is negative or grounded, and we have only one unknown, that is V1 at the top, and we always assume currents are leaving from positive and it is traveling through the branches and hitting the ground potential, in this case at point D. What exactly is V1? V1 is nothing but when we connect a multimeter such that the positive is connected at the top and the negative is connected to the ground as indicated in that point D, what does that voltmeter read? It reads V1, right? What exactly is V1? V1 is voltage of across 2 or 4 or 28. How is it? What is it exactly? Let us understand. These two are in series, that is 4 and 28, right? And this entire branch, first branch, is in parallel with 2, right? And again first branch, second branch and the third branch, all three branches are parallel. Thus we know in parallel voltage remains same with polarity. That means at top it is positive for all the three branches, and for all the three branches at bottom it is negative. That value is V1. How do we calculate? It's very easy using a multimeter. But how do we calculate and get the right answer? Let's observe. So here I've just assumed that when we neglect the other two branches, how can I write the equation for I? Right? We need the correct equation for I1. So let's see that. How do we write the equation for I1? This you need not do always. I'll understand the concept, then I'll tell you. We'll just based on that concept, we'll follow a method. How do we incorporate the equation for I1 in a simplified manner? Now we mark the polarity across resistance by passive sign convention, plus minus. Now I1 is traveling in anti-clockwise. Again, I would repeat, we have assumed the current leaving a junction. Because of that, current is traveling in anti-clockwise direction, and because of that we will be applying KCL in anti-clockwise, right? So here this drop highlighted with arrow mark, that is V1, where red indicates positive, black indicates negative. So how do we write equation for KVL? 4I1 plus 28 minus V1 equal to 0. Now we want I1 is equal to V1 minus 28 by 4. I repeat, this we need not do, anyone need not do this every time. So once you understand the concept, later on we correlate with a shortcut. You can always use that method later on. Not this. This is just concept. So let's see how can we understand this. So by Ohm's law we know I is equal to V by R. V is the total voltage in that branch, in the first branch, divided by the total resistance in the same branch, in the first branch, right? So let's understand this. Let's take an example, or let me explain this equation first. So you can see the current I1 is traveling from red dot. The current I1 is traveling from red dot. Red indicates positive. Thus V1 is also positive. As the current travels, it hits which polarity of 28 first? Positive. Thus it is negative in the equation, right? Next, in the first branch, you can see in the first branch, which all resistance can you observe, or which all passive elements do you observe? It's only one, that is 4 ohm. So divided by the total resistance in the same branch or in the first branch, that is 4 ohm, right? So let us take one more example. So what if we have 2 ohms in series? Then how do we write, right? So the answer is V1 minus 28 by 6. How did we get 6? 4 and 2 are in series, thus it is 4 plus 2, that is 6 ohm. What if you have 8 volts in series now? So in first branch we have two voltage sources and two resistances. Now how does one incorporate this? The current I1 hits which polarity of 8 volts first? Negative. Thus we write it as positive. So it is V1 plus 8 minus 28 whole divided by 6. So you can see, once you understand the concept, you can write the equations directly. Right? So now let us go back to our original question and write down the equation for I2. Now current I2 is traveling from positive of V1. There is no other voltage sources. Right? So V1 divided by 2 would be the right answer. Similarly I3. In third branch, the total voltage, the current is traveling from V1. V1 is positive, and the current hits which polarity of 7 volts first? The current is positive terminal, thus it is negative here. And what all resistance are there in third branch? Only 1 ohm. So divided by 1. Right? So now if I apply KCL at V1, we write that as 0 is equal to I1 plus I2 plus I3. So what all the equations you have written below for I1, I2 and I3, substitute them in the above equation, add them, and you can see here we have only one unknown. Which is that one unknown? V1. As we discussed earlier, the number of junctions are 2. Thus the number of unknowns would be 2 minus 1. One unknown. And what is that one unknown here? V1. So if we solve for V1, we get the answer as 8 volt. So if I keep a multimeter positive probe at the top, negative probe at the bottom, we get the answer as plus 8 volts. Right? So this is how we solve. Now when I substitute the value of V1 for I1, I2, I3, the answers are minus 5, 4 and 1 ampere respectively. So I1 is flowing downwards, I2 is flowing downwards, I3 is also flowing downwards, and you can see there are minus 5, 4 and 1. Now what does this minus 5 indicates? What does this plus 4 indicates? What does this plus 1 indicates? So minus 5 indicates that the current direction that we have assumed, it's not wrong. It's actually flowing in the reverse direction practically when we build the circuit. And what does 4 ampere indicates? Plus 4. That means current is flowing in the same direction practically also. And what does 1 amp indicates? The current is flowing in the same direction practically also. Right? So let's solve for Vx. Vx is voltage across 4 ohm. So by Ohm's law we know V is equal to I into R. So R is 4. How do we find the current, or which current is flowing through 4 ohm? It is I1. That's correct. But can you observe I1 hits which polarity of Vx first? It hits negative polarity. You can observe I1 hits negative polarity of Vx first. Thus the right equation for Vx would be, or the right equation for I with respect to Vx would be minus I1 into 4, where minus is substituted because the current hits negative of Vx first, and the value of I1 is minus 5. So the answer is plus 20. So when I connect a voltmeter of that polarity across 4 ohm, that is plus at the bottom and negative at the top, I get a drop of 20 volt in that multimeter. Next, let's find Ix. Now one can observe the current I3 and Ix both are flowing in same direction. Thus we write the equation as Ix is equal to I3, that is equal to 1 ampere. Now let us say that the question is asked to find Iy, right? So you can observe in the second branch the current I2 is flowing downwards, right? But Iy is flowing upwards. So these two are in opposite direction. One can observe current assumed I2 is traveling opposite direction with respect to Iy. Thus Iy is minus of I2, which is minus 4 ampere. Thank you.
Thank you for watching the video. Please subscribe our YouTube channel to enhance your knowledge. Thank you.